So now it is my pleasure to introduce you to the speakers today. I am delighted to be joined by Ed, Optibrium's Chief Scientific Officer. After graduating with a degree in mathematics in 1995, Ed joined GlaxoWellcome, working as part of a pioneering team building predictive pharmaceutical tools. He developed the first graphical user interfaces for working with predictive models, which were adopted globally within GlaxoWellcome. He was a core member of the team, which established the UK operation of Chemetral in 2001, and remained with that company, now operating within Biofocus DPI following merger and acquisition, until 2008. During this time, he designed and built the StarDrop software and, in 2009, co-founded Optibrium. So Ed, are you ready to get started?
Yes, thank you very much, Sophia. Hello, everyone. Thank you for joining today's webinar. My name's Ed. I'm the CSO of Optibrium, and it's a pleasure to be able to present to you today. As a quick overview, I plan to give an introduction, but my main focus is going to be a live demo, after which I'll answer any questions that you have. Now, by way of introduction, I'm going to be talking about StarDrop. And for those of you who don't know me, I've been part of the StarDrop project since its very beginning. This goes back before Optibrium even existed. Indeed, it goes back to before StarDrop was even called StarDrop. Right now, I'm going to be focusing on where we've got to today. But before I do, I'd like to give a little bit of context based on some of that history. Ever since the earliest versions of StarDrop, we've always had a long list of innovative features that we want to get into the software, things we want to develop. So a common theme in previous StarDrop releases has been to introduce the next new shiny piece of functionality from our list. For example, bringing in Nova, which was our first foray into generative chemistry when we launched StarDrop 5, or when we introduced CardView in StarDrop 6 to provide a new way to work with compounds data. They're both examples of themes which took a long time to come to fruition. Now, of course, we also try to work into our plans the things that you tell us about or ask for. And this release is a little different because the whole premise of this release is entirely driven by a consistent message that we've heard in your feedback. Indeed, we've had more feedback on this particular issue than we've ever had about any other aspect of our software. So what is it that everyone has been telling us we need to deliver? Collaboration. You've told us time and again that you want StarDrop to ensure that you are looking at exactly the same compounds and data as your colleagues. When there are new assay results or new ideas, the whole team needs to know. So why is that such a big thing for us? Well, some of it comes down to the way that we develop StarDrop. At the outset, StarDrop was designed as a desktop product because we wanted to build something highly interactive, something everyone could use to look at the data whichever way they chose. And of course, when we started, the internet was a much simpler beast. A web page was something you read with a few simple links to take you to related material. There was no such thing as a webinar, a meme, or social media. And JavaScript was very much in its infancy. Now, as it happens, StarDrop is also available through a web browser these days, but it's still the same product underneath because we don't want there to be any difference in the user experience. Regardless of how it's accessed, StarDrop has matured as a standalone product. And just like in all other facets of life, when someone or something is not used to playing nicely with others, it takes a while to adapt. However, even more than this, we wanted to have our cake and eat it too. We wanted to go well beyond the typical experience of working in a shared document or spreadsheet. If you consider a typical Office product, whether that's from Microsoft, Google, or another platform, when you're sharing, everybody sees exactly the same thing, the same words, the same paragraphs, the same notes, the same comments. Importantly, too, only the people you want to see and edit the document or spreadsheet can do so. We wanted to make sure we provided this same level of consistency and security for compounds and data. If a user adds a new compound, the rest of the team needs to see it in real time. When colleagues add new data or comments, the rest of the team see these straight away. But continuing to think about a shared document, now imagine You can change the fonts, you can change the colors, you can change the background or the design, the layout. All of this without inflicting your personal preferences upon everybody else who's working on the document. This probably isn't so helpful for a shared document, but for compounds and data, this kind of freedom enables each member of the team to create whatever visualizations and analyses they wish, look at the data in whichever way they want, sort the data, investigate particular subseries, whatever it might be. Complete freedom to explore, but without impacting other team members. Yet underneath it all, exactly the same compounds and data. We knew it was important to maintain this level of flexibility that StarDrop users have always appreciated. So we needed to create something a little bit more complex than a shared document. And you can probably imagine my colleagues in the development team weren't overjoyed as I laid out my list of requirements. Let me show you what we've done. It's my pleasure to introduce StarDrop 8. Every major scientific discovery has one thing in common: the right tools at its core. For 20 years, we've built software that doesn't just support discovery, it's central to it. StarDrop 8, our latest, most advanced release, ensures that teams stay aligned in real time, eliminating efficiencies and tracking ideas with complete clarity, so no breakthrough is ever out of reach. So what are the kind of challenges you've been telling us about? Firstly, you've told us that you want your global, hybrid, or distributed teams to remain in sync. You can't afford them to be misaligned or be anything other than up to date when it comes to project data. Regardless of distances and time zones, you want your project teams to have a consistent picture of the latest compounds and data to avoid duplicated efforts. You also want your team members to be able to work just as flexibly as they always have with StarDrop, but to be able to share their insights with others. And finally, you want your team members to have a shared view of all ideas so that you can learn from past decisions. In order to address these challenges, there are 4 key concepts within what we've put together that I'll describe very briefly for now before I give you a demonstration of how it all works together. The first of these is collaborative projects. These provide shared spaces for your compounds, and they enable you to define a team and keep that team in sync so that you can drive innovation and progress faster within your projects. Within these, you then have shared data sets which provide that single source of truth and ensure real-time alignment. Working with these data sets, each person can create their own workspace. Workspaces enable all team members to analyze and visualize project information in their own way. And all of this sits on top of centralized idea tracking to capture designs and decisions across all of your projects throughout the discovery process. But I think the best way to convey all of this is to actually show you it in action. So here we go. I'm going to bring StarDrop across into my screen here. And here we have StarDrop 8. And for those of you who are already using StarDrop, I'm sure this looks pretty familiar. Although I'm sure you'll spot 1 or 2 things that are at least a little bit different. However, I'm aware that across the audience today, there are a range of levels of familiarity with StarDrop. Some of you have used it for a long time. Some of you are very new to it or haven't even used it before. So to start, I'm just going to give a bit of a description of what we've got going on here. This is actually a project that I've already created. Indeed, it's actually a workspace sitting within a project because I thought it'd be more interesting to start from something I'd already put together rather than build it up from scratch during the demo. But let me describe what you're looking at, and I'll get back to all those different concepts I mentioned earlier as I could go through the demo. So the first thing to say is we're looking at a set of 5-HT1A compounds. So this is an anti-anxiety project. I've got a small library of just under 250 compounds in this particular data set here. We can see that at the very bottom. Over on the left-hand side, I've got a very simple visualization showing the number of compounds in this data set that we have in each of the 6 different chemical series that are represented. So you can see that we've got compounds, some of which are indenols, got some aminotetralines, some aryl piperazines, and so on. So just a very simple sort of summary of those 6 different chemical series. Indeed, they're shown in this column, which is just off to the right-hand side here. So each compound is given a category flagged up. The dataset itself has a number of different columns, and again, I'll describe what's going on. We can obviously see the structures and the IDs, and most of these compounds have been synthesized and run through a primary assay, and we can see that we've got some measured affinity data against 5-HT1A here in this column here. So these are pKi values, and this dataset happens to be sorted with those highest values at the top. So you can see we've got some nice high pKis there. We've got a notes column here. I'm going to come back to that in a few minutes, but we can see 1 or 2 thoughts that different people have put into this data set. And as I scroll further across, we've got a number of different predicted properties. Many of these come from our ADME-QSAR module. And just as a quick aside, I'm going to hop over to the models area just to show that we've got 1 or 2 updates to this in StarDrop 8. So we have a new model for intrinsic clearance. We also have an Ames category model, and a few of the other models within that list have been updated with sort of bigger data sets, and so we've got better models there now. We also have, within StarDrop 8, a much expanded list of, I'm going to call it simple properties or descriptors that you can calculate. Simple properties list you may recognize from before, but down here we have a number of descriptors that allow us to see atom counts, functional group counts, along with ring counts. So again, these are things that you've asked for, just simple ways to add these counts into data sets quickly and easily with StarDrop. So hopefully these lists are useful for you as well. At the front of this data set, I've got a column of MPO scores. So these are scores against a profile of properties that we've put together where we're looking for a potent compound against an oral CNS target. The profile that I've used for this, we can see here in the scoring area. So the profile is made up of a number of properties that we've decided are important for our compounds and against which we want to sort of judge our compound's likelihood of being successful. For each of these properties, we've indicated a desired value. It could be a range, it could be some kind of trend. So a desirability function that reflects what we know about what we'd like to see from this property for an ideal compound. So in the case of the potency, ideally we'd like a really high value, but we're willing to accept values sort of a little bit below that, sort of trending off. So the way we set up these criteria can vary project to project, but in this case, I've defined a set of criteria I like, and for each of the properties indicated its relative importance to the other properties in that profile. Relative importance, I should say. So in this case, again, we've said potency is the most important thing, followed by solubility and absorption. So I'm not telling you this is the right profile. Each of your projects will have a slightly different profile that you might be using. But in this case, this is the profile I've used to generate the scores that we can see here in this first column. The scores are values between 0 and 1. 1 indicates complete success, 0 complete failure. Not surprisingly, being probabilities, most of the numbers we see are somewhere in that range. So we'd like to see higher values because a higher value indicates compounds that's more likely to meet the criteria that we're interested in. And the little histogram gives an indication of how well it does against the different properties in that profile. So in this case here, we can see log P and with HERG aren't looking quite so promising. And that's one of the reasons why this score is not as high as some of the others. If I sort this data set in descending order, we can bring the highest scoring compounds to the top of the list. So we can see we've got a few compounds in this set, which have got some nice high scores. They're doing well against a lot of the properties in the profile. And therefore, yeah, we'd be confident that these have a good chance of being successful. So all of this is sort of just a recap of the kind of things that we've had in StarDrop for many years, but for those of you who haven't seen it before, hopefully that gives you an idea of what we're looking at. But this is a shared data set. So this is a data set that I'm sharing as part of a project with my colleagues. What that means is that any changes I make to this data set are going to be seen by my colleagues immediately, in real time. We've got a notes column here, and actually none of these alpyrazines, which seem to dominate the top of the list here, seem to be doing particularly well. seem to have any notes. I mean, they're all doing very well in terms of the scores. But we can see here, this interval here is actually sort of the highest scoring interval in the list. One of the reasons it's got a lower score than some of the others is it's got a bit of a perhaps a little bit of a problem when it comes to the Hurg affinity, but it looks quite promising. So something I might do is drop a note in here and say, promising, but watch Hurg. And if I add this note into the data set, this will appear immediately my colleagues who are also looking at this library. So any colleagues with whom I've shared this data set are going to see any notes that I add into it. Equally, if any of my colleagues are working in this data set as well, and they make changes to any of these compounds, they're going to appear for me immediately. Now, anytime anyone makes changes, we're going to get notifications. So down in the bottom right corner here, we can see a little notifications icon. It shows that I've got a number of different notifications. These tell me about different things that have happened to data sets or projects that I've got access to. So this gives me an idea that there are things that I might want to go and check out, changes to compounds or data. Within the data set itself, what will happen when somebody makes a change, as my colleague Alessia has done while I've been talking to you. As you might imagine, it's very hard to demonstrate collaboration without somebody else with whom you're collaborating. Any changes that somebody else make will appear with a little indicator here. So I hover over this little indicator in the sort of the right here. Actually, if you keep your eye down in the bottom left corner here as I do so, you'll see that a little indicator is telling me that who updated that change and when they made it. So these allow me to keep track of anything that has recently changed, so that I can sort of keep on track of the latest updates. Now, I happen to know that Alessia has also been making changes by not just modifying notes in the dataset, but adding compounds to the dataset. Now, of course, I've got the dataset sorted the way I want. So when other people are adding compounds to a dataset, they automatically get put at the bottom so that it doesn't disrupt the way I'm visualizing or analyzing the data. But if I happen to scroll down to the bottom here, we can see we've got a new row here. There's a couple of indicators it's a new row. Firstly, we've got the nice indicator on the row itself telling me that. Secondly, I can also see that it's a virtual compound. It hasn't got an identifier yet, hasn't got any measured data yet. And indeed, the score looks a little bit sort of faded out. So again, for those of you not familiar with StarDrop, MPO scoring will work for any compounds, and regardless of the data you have available for them, and regardless of the uncertainty in that data. But when you have missing properties from the profile, the faded out profile is just an indicator that we've calculated the score despite the presence of, or the absence of data, in this case, the missing PKI. For all the other properties, you can see that StarDrop can calculate them very easily. So I said that I was sharing this data set with a colleague of mine. Up here in the new Collaborate menu, we have access to the way we can manage projects, workspaces, and data sets. So if I pop down to data set here, look at manage access. So we can see in this data set that I have given everybody editor access. I'm the owner, and as editors, what this means is that everybody with access to the project can make changes to the compounds and data within. If I wanted to give people more specific privileges, I can easily do so in the share area and start typing name and choose what access to give them. So I can give I have complete control as the owner of this data set to choose who can make changes, who can't. But in this case, I'd like to make sure that everybody working in the project team can work on this data set. I trust them all. I've assembled the team, and I want them to all be able to work together. If I have a look in the Collaborate menu, we can also see that under the Datasets menu, I have the option to configure what I'm looking at. And we can see here that within the project, I've got access to 3 datasets, but I've only got 2 of them open. So we can have multiple datasets in a project. We don't have to have them all in our workspaces and have them all on view at the same time. We can see here that I've got another dataset here that's been shared with me by Alessia. Indeed, I'm only a viewer of this data set. So if I tick OK, this will be shown now within my workspace. I've still got the original data set I was working with, but I've now got this data set too. And this is a data set that Alessia has shared with me, but you can see it's got a grey background. And whether I'm in table view or card view, when I'm a viewer of a data set, I can't make changes to it. However, I click on it and it's sort of indicated to me. If you're eagle-eyed, you'll notice that there's a slightly different indicator on the dataset label. There's a little lock there showing that I'm allowed to access this dataset, but I'm not allowed to make changes to it the same way that I can with this main library. When I open this up, it was showing card view, and again, just for those who aren't familiar with it, I can describe what we're looking at here, because this is a data set that we can see from its name, which is a sub-series of the aryl piperazine compounds labeled S10. If we zoom in on it, we can see it's been laid out in card view with a neighborhood analysis, sorry, with a neighborhood view around this reference compound. So S1014 we've picked out as an example. The compounds have been laid out around it based upon their chemical similarity in a spiral. I'll just zoom out for a second. You can see that spiral of similarity. But we're zoomed in having a look at some of the sort of characteristics of the compounds, because the way the spiral's laid out, the compounds are linked back to the reference with these arrows to show the change in a property, in this case, potency. So where there is an increase in potency, the arrow is pointing towards the higher value. So that allows us to see where there is a change in potency between similar compounds. And the intensity of the color of the arrow, the more orange it is, shows that there is a bigger increase in that difference between the two compounds. So we can see with this second compound around here, there's a bright orange arrow. The reason for that is we can see there's a 2 log unit difference in the potency. The way the cards are colored is actually from sort of blue through to yellow with green in the middle. They're colored on the basis of the stability of the compounds. So the most stable compounds are yellow. It's got a nice half-life against CYP3A4. The least stable are blue. We can see a very blue one here. There's a much shorter half-life. And again, the colors are there just to show sort of a comparison between the compounds. In this case, it's sort of just an interesting pattern challenge for this particular series. We can see these two compounds side by side. One of them is nice and stable. One is very unstable. The only difference between them relates to the position of the methoxy on this ring here at the end of the compound. So that's the only difference between the two, and yet that accounts for a big change in stability with this compound with the methoxy at the para position particularly stable, but this is far less potent. So we can see there's almost sort of 2.5 to 3 log units difference in potency between these two. So when we can get great stability, we lose a lot of potency and vice versa. So it's one of the challenges of working with this data set. So this is why Alessia shared this particular visualization with me in this data set that she's been working on. Just because it's a read-only data set doesn't stop me interacting with a compound. So if I wanted to perhaps come up with some of my own ideas, I could pick out the first compound in this data set. I could pop that into its own new data set, and very quickly with the designer, I could start working on my own ideas that I'm interested in exploring further. So I've created a data set. I haven't made any changes to the shared data set with me. The new data set I now have available is currently private to me. So just because I'm working in a project doesn't mean that everything that I do has to be shared with everybody else. So I can continue to work to my heart's content. I could add new ideas here. I'm being very unimaginative in the ones that I'm adding here, but simply to show that I can modify this data set to my heart's content. If I'd like to share this with other people, then I need to add it to the project, but that's very much my choice. So when you're part of a project team, you can still work individually and privately, but when you want to share, the flexibility is there to do so. So what I might want to do with this data set, if I go to the share menu here, I'm going to be prompted to be told that one of these data sets is not yet uploaded to the server. So I'm going to say, yes, please do that. That gives me the chance to share it. And now what I might want to do is share this data set back with Alessia. I'm going to give her viewer access to this data set. And it will give me a reminder I've done this. And now when Alessia is working in the project, she'll be able to choose whether or not to view this data set within her workspace. She'll see a notification appear down in the bottom right corner here telling her that she's been given access to a new data set, and she'll be able to access it. So now the two of us can get to this, but none of the other project team members can do so. So all of the sharing we've done so far is within the context of the project itself. If I pop up to the collaborate menu again, we'll see I can have a look at the project. So the project team, I've set this project up myself, and I've got 4 different members this project. And if I'd like to invite other people to be members of the project, I can do so easily. So if I start adding names to this list, I might choose that Harry's going to be joining us on the project team. And so he will now see a notification that tells him that he's been added to this project. He will automatically have access to anything that's shared with everybody, but nothing else. So all the other things that have been shared individually, the data sets Alessia shared with me and vice versa, that we didn't share with anyone else, Harry won't know anything else about those, but he will have access to the main library that we've shared with everybody. So we have the ability to control, define the team of people who can collaborate together. And then within that team, people can share individually. So there's a lot of layers of flexibility and control to allow you to collaborate with whomever you like. As we're working in a project, one of the things that we've also added in StarDrop 8 is a project journal to provide a way of sharing information at a higher level than any individual data sets. So the journal is really a way to sort of capture maybe a flavor of what's going on, perhaps an update on the data sets that are available. In this case, I've simply added notes of the 3 different data sets that I had access to. Obviously, I've added a new data set, so I might want to start editing the journal and start adding notes so that other people will get to see these. So the journal is open to everybody, but it's a way to provide information for the whole project team, sort of at, as I said, a level higher than individual data sets. Something else that is also going on behind the scenes, you may have noticed when I was starting to add brand new compounds that I got idea tracker IDs automatically added to these compounds. I've got a little data set here with some compound ideas in it, with some examples of this going on. This is something that was created very recently. We can see that this small data set here, we've got not just idea tracker IDs given to all the compounds that we've added, but if I scroll across, we can also see that for every compound, we have a creation timestamp, an indicator of the source of the compound. We can also get an identifier, which tells us the compound from which the new idea was derived. So whenever compounds are added into StarDrop, they will automatically get this birth certificate information. If the registry, if your idea tracker is connected to your compound registry, then registry IDs can also be pulled back if they exist. So if you draw what you think is a new compound, but actually somebody else has already come up with it, you'll see this represented in the birth certificate information. You'll see when it was created. And if it's something that's been created a long time ago and has already been registered, you'll see the reg ID for that compound as well. So these compounds, it's a very small data set here, I've actually got colored in card view such that I've got a sort of an indicator to the status of the compound. So if as you're creating new ideas, you want to sort of track how those ideas are progressing towards synthesis and beyond. In this case, I've just used a little bit of color to indicate a new idea relative to ideas that have been parked or that are going through idea validation. And we can organize the ideas on the basis of that parentage that I mentioned that gets automatically captured. So if I connect things up based upon their parents and put these into a sort of a top to bottom hierarchy, we can quickly see the sort of the originating compound from which the further ideas were derived, and sort of see their relative status as we go through that. We can see one of the examples here wasn't derived from any of the others. It's sort of separated from the network that we've got displayed. So all of the idea tracking is really going on just behind the scenes. So regardless of what you're doing within StarDrop and regardless of how you're collaborating with anyone else, every new idea that goes through StarDrop will be automatically given identifier so that it can be tracked seamlessly. The last thing to mention is that I said earlier on that one of the really important things that we wanted people to be able to do was work completely flexibly. So although I've been collaborating with Alessia and I've sorted the data set earlier on while I was doing that, how I'm looking at the data doesn't force anybody else to look at the data in the same way. So even if Alessia's got this data set open, she doesn't have to have it sorted based upon scores. She could have a heat map going on, whatever she likes. Each person can look at the data, take a view of the data that suits the analyses that are important to them. Indeed, what I've done is actually create another workspace within this project looking at this. So we refer to the way we're looking at everything, this view, as a workspace. I'm going to open up another workspace looking at exactly the same data set here, but you'll see that it's displaying everything completely differently, despite the fact that underneath it, I've got identical compounds and data. So if I go to File Open, in this current project, I've got a different view, this space view. What I'm going to do is discard the changes I've made, but it's prompting me in case I wanted to keep the different way I've sort of added data sets and laid things out. And discard that and load up what is a completely different view of the world, in which I not only have some sort of different visual representations of the data set. I'm using card view. I actually got a dashboard that I created that was part of it. Apologies, that popped off my screen over to the right. The key thing to say is that all of this visual representation that I created in a separate workspace sort of is maintained independently of the underlying information. So although I've got a snake plot here of the scores, and I've got a category matrix, sort of looking at sort of 2d6 affinity across the different chemical series, it doesn't change what anyone else needs to look at or the visualizations that anyone else needs to create. Indeed, here I'm looking at this same 5HT1A library. It's the only data set that I've got open in this particular workspace. And here I've chosen to lay out all the compounds based upon common substructure clustering so that I can see where I get sort of good quality or high quality compounds in terms of their potency and where they lie within this sort of structure space. The left-hand side, I've got a chemical space, so just sort of a comparative view. This is laying out all the compounds coloured on the basis of those chemical series, but each compound is represented individually rather than clustered on the basis of a substructure. So I wasn't going to dwell too much on the specifics of these different visualizations. I simply wanted to show that I could have these multiple views onto exactly the same compounds and data as though I'm a different user. So each user can have as many views as they wish for looking at the compounds and data, that complete flexibility that I talked about earlier. If what I'm looking at I think is important for other people to see, I can also share my view. So I could take my workspace, I could choose to share this, and as I've been working with Alessia, I might decide that I want Alessia to be able to see perhaps the results of the analysis that I've done. What I'm going to do is share this and give Alessia viewer access. What that means is that Alessia can see everything I'm looking at, but if Alessia makes changes to the way it's laid out, she'll be prompted to save her own copy of the workspace. She can't overwrite what I'm looking at. So it means, again, I can share my insights, anything I find very easily with any of my colleagues within the project team, and allow them to either work on those with me or work from them as suits them best. So hopefully I've given you an interesting introduction to how we're bringing collaboration to StarDrop. One of the things, I guess one of the key things I was really keen to do is make sure I highlighted that everything that you could do before in earlier versions of StarDrop, you can still do regardless of whether or not you're using the collaboration functionality to its fullest. Ultimately, you can still get exactly the same StarDrop experience, but now it can be collaborative. This was a really important part of this project for us. So I'm going to end the demo there and just pop this out of the way again and switch back to my slides. I highlighted some of the key challenges you told us about earlier, and I hope I've managed to give really a feel for the way the key elements that we've built into StarDrop collaboration address these.
Thanks for such a thorough and well-considered presentation, Ed. As a reminder, if you have any questions, please add these to the Q&A panel at the bottom of the screen, and we will work through as many as we can with the time left.
So the first question I've got here is, when can I try this for myself? Well, the short answer is as soon as you wish. The slightly more rounded answer is that to get a feel for the collaboration capabilities, you really need to try it out at the same time as a few other colleagues, which takes a little bit more coordination. Now, we've established a good process for doing this, so please get in touch as soon as you'd like. We'll be happy to get you and your colleagues set up to give it a go, to try it out. The next question is, how is this licensed? As you can probably imagine, this is something that you would license at an organizational level. I know within StarDrop, we have lots of flexibility for individuals to use or share different modules. But in the case of all the collaboration capabilities, it's something you would license for all users. This doesn't compromise what you can then do. So all the rest of the licensing and all the flexibility of the licensing we already have remains the same as it always was. So users aren't all required to work with exactly the same set of license keys just because your organization is now using the collaboration framework. The next question is, how does this change what I can currently do with StarDrop? That's really easy in that it doesn't change what you can currently do. You just have more that you can do, as hopefully I've given you a flavor of today. There's nothing that's been compromised in terms of your current experience, only improved. We've got a question from someone who's interested in the CNS scoring profile. And the question is, how are these profiles put together and how did you determine the properties and their desired values? So the profile that I was showing you is really just an example. Let me show you StarDrop again. I'll just pop the window back in briefly, switch to the scoring area, and let me pick one of these example profiles. So at the bottom of StarDrop, we have a number of example scoring profiles we provide for everybody. You don't have to use them, but they're simply there to give you a flavor of how it is that you might put a profile together. To make them accessible to everyone, they're simply based upon predicted properties to give you a starting point. However, ideally, you'd include in a profile all the properties that are important to your project, whether they're measured or predicted, whether you've got values for all your compounds or not, whether those are uncertain values, whatever it might be. So scoring profiles are completely flexible and should be tailored on a project-by-project basis to reflect your understanding of the goals, which may, of course, evolve during the course of the project. In the case of this oral CNS scoring profile example, we've got properties like human intestinal absorption and solubility at the top because it's an oral profile. These are clearly important for achieving that. We've also got blood-brain barrier penetration in the mix because if you're looking for a CNS compound, you're going to need this. Now, if you're building a profile, particularly if you're doing it for the first time, you'd like assistance from us in choosing properties or choosing the way that use properties together or set desired values or relative importances, we're always happy to help. Please just get in touch and we'll do our best to assist you. The next question is asking, can the workspace be integrated with scripts that, for example, send ideas off for calculations in other programs? For example, automated docking. Yes, absolutely. We already have, for example, the pose generation interface in StarDrop that allows a user to send off compounds for docking and then bring the results back into your dataset. If this dataset is shared with others, they would automatically get those results. So you could send off requests on behalf of anyone else with whom you've shared the dataset. So really what we've done only improves the flexibility when you're using additional in-house or third-party calculations or data sources that you want to bring in. Everybody in the team with whom the data is shared will be able to access the results. Importantly, each user can configure their workspace to see the aspects of the dataset most important to them. So if a colleague is working on something and you don't want to see it, you don't even need to look at the data in your workspace, but you have the freedom to choose to do that. Another question is there a way in StarDrop to drive decisions within teams? For example, agreeing with the teams which compounds will be made. Yes, Now, firstly, the shared view ensures that everyone in the team has the same up-to-date picture of the latest compounds and data. When you combine that with scoring, you quickly see how everyone can have the same idea about which compounds look promising in terms of their properties. The annotations we demonstrated show you how easily all users can share their insights and thoughts on the different compounds. But of course, you could capture some of the high level considerations or decisions within the project journal. So if there are particular stages of the project that you were trying to achieve, or a particular series on which people were focusing, more notes and sort of annotations as to the decisions made could be captured here too. So this could be particularly helpful if the project goals change over time. The next question is asking, is there an AI type of generator for molecules? So we have within StarDrop the Nova module, which provides a number of different methods for automatically generating compound ideas based upon the starting point. We then have a module called Inspirer, which provides means by which you can use automatically generated compounds in the background. And while it's doing so, you can provide feedback on the compounds from which it will learn what you've said you like, what you dislike about the compounds in order to provide you with new ideas. So I'm not going to dive into a live demo of this now, but would be very happy to follow up and do so with a little more time. The next question is, how many people can access StarDrop 8 at a time? There is no hard limit on that. We're working on the assumption that across the project team, it's unlikely that everybody's going to log on and use it at exactly the same time, but we have no built-in limitations. So if you are working as part of a large organization, you're clearly going to have more people in the project teams, and they can all work together collaboratively. The way we've set up the infrastructure is tiered to accommodate this. Another question is, can you add structural data? For example, a docking model with a target protein structure. Yes, so this is something you can already do in StarDrop. So again, there was an earlier question about how you might be able to run a script to call docking model and then bring the results back into StarDrop again. I haven't got 3D data in this particular demo, but anything I did have in this data set, if it is 3D confirmations or those results from docking, they could be shared with any members of the team. There are a couple of questions around process, information security, and data storage. So the first of these is the data in the workspace stored locally or in the cloud? It's all stored in the cloud. In the case of this demo, I've been working with a StarDrop client, which is on the desktop, but whether you're using the desktop version of StarDrop or the cloud-based version, the data itself gets stored in the cloud. I can create, as I showed earlier, a data set privately for myself. I don't have to upload it into the project. I could save that out as a file onto my desktop if I wanted to. So none of this forces you to put everything into the cloud, but for collaboration, the data need to be in the cloud so that other users can access it. The next question is how the data and projects stored. They're all sitting within a highly secure database within our AWS infrastructure. All of this will be separated from organization to organization to sort of protect each customer's data. Yeah, that's where all of the data reside. The next question is, do you have any plans to add more advanced machine learning methods to AutoModeler? And if so, when will that be available? The short answer is yes, we do, but I can't tell you when it will be available. You're going to have to watch out for future papers and presentations. If there are particular algorithms or features you're keen to see, then we'd love to know more about your thoughts, so please get in touch. Another question is, can I use collaboration to work with a CRO? And the answer is absolutely yes. Now, how you do this is very much depends upon your relationship with that CRO, but you could run a project exactly as I've got set up here. You would create accounts within your organization setup for the members of the CRO that you would like to be able to access the project. And then you would invite those accounts to be a part of the project team and share data sets with the CRO that you'd like them to see. So in this case, I may not want the CRO I'm working with to have access to the full library, but I might want to share a small data set with ideas that perhaps that CRO is synthesizing with them, possibly just with viewer access, or maybe I want to give them editor access so that they can update that with information about the progress that they're making. But you can certainly work with one or more CROs as part of a project and then choose what subsets of data you'd like them to have access to. One final question is the future plan for startup to enable compound registration, for StarDrop to enable compound registration functionality. We haven't got immediate plans to do this. One of the reasons for this is that there are a lot of very nice systems out there for doing this already, and StarDrop can integrate with them pretty seamlessly. As I showed when I was doing the idea tracking, that can be connected directly to a compound registration system. The idea tracking capabilities I was demonstrating provide somewhat equivalent functionality to this, but of course what we have in StarDrop is purely for virtual compounds. For the time being, we're assuming that when using idea tracking, you'll want to hook it up to your compound registration system so that you can align identifiers automatically. Once integrated, anytime you add new compounds to StarDrop, it can go and check your registration system so that if an idea has already been registered, you can see the ID there as well as in the idea tracker ID. So from our perspective, our focus is on providing that seamless link between the two, but don't have any immediate plans to develop our own right now.
Thanks, Ed. That's all we have time for today. Details of our next webinar will be available on the Optibrium website and LinkedIn page shortly, along with other helpful news and information to help transform your discovery. All that's left for me to do is thank Ed for an insightful talk. Thank you all for coming, and we'll see you next time. Bye for now.